Welcome once again, Sansar Solutions. So today we are going to present the assembly production drawing of knuckle joint. So these are also one of the important joints. So what we are going to discuss in detail. So let us focus on. So what kind of the question we are going to get? So it is similar. So they given the assembly. Assembly is given here. The moment if you see that this is knuckle joint, then what you have to draw? It's a component drawing weaves you have to write. Then you have to write the fits and tolerances. Then you have to write the geometrical tolerances. Then you have to write the surface finish. The finally process sheet. These are the questions will be covered. So now let us focus. So what is knuckle joint? So knuckle joint is nothing but it is used for connecting two rods whose axes either coincide or intersect and lies in one plane only. So want to connect two rods. So whose axis will be axially or it will be coincides. So we have to connect. So these are the things we are using here. So where can you find this? These are widely used in tractor trailer. So tractor has to carry one trailer. Though you can see this, one fork end will be there, one eye end will be there. Eye end connected to the trailer, fork end connected to the tractor. So that these both are connected, pin will be joined here. So then this coupling. So the tractor can pull the trailer. So this become a single unit. So those purpose we are using for this knuckle joint. So joint between the links of suspension bridge and also used in steering system. In between the steering rod and pinion of steering gears. So these are the things we are using. The knuckle joint is used to connect two rods under the tensile load. That's very, very important. So we used to connect the two rods, tensile load. So one connect to the tractor, one connect to the trailer. So it is like a tensile load. So for wherever you're going to use the tensile load, there where you're going to use knuckle joint. Now the knuckle joint consists, so major the 5 parts. What are those? The 5 parts are, so this is number one. Number one is called a fork end. Number one is called the fork end. So number 2 is called eye end. Then the number 3, this portion is called pin. So number 4, this is called collar. Then the number 5. The number 5 is this is number 5 is taper pin. So these are the 5 major parts which consist the knuckle joint. So what are those points? Again it is the fork end, the eye end, and the pin, the collar. Finally it is taper pin. So these are the things. Now the first question is draw the important drawing waves, the component drawings. So our solution is, this is the first question. The solution for the first question, draw the component. So what are the details? The details is I told this is the fork end. Yes, of course it is a fork end. The front view, the top view. Then it is eye end. Again the front and the top. Then it is pin. The pin, front, the top. Then it is collar. The front and the top. Then it is taper pin. So whenever you're going to draw a detailed drawing, first you have to understand the assembly, how functionally where it is used. Then it is very easy, detach the part and draw. So that completes your knuckle joint. Yeah, if you want more clarity, just to see the 3D figures of this knuckle joint, how it looks like. So now I showed the eye end, the 3D, this is the 3D dimensional figure, how it looks like. Three-dimensional figure. Yeah, this is a 3-dimensional figure. You can see this, the eye end. The eye end looks like this. So then it is the knuckle pin, they're going to come here. Then it is a collar. Then you can see the taper pin. Now this is the fork end, just you can see this. Then finally, so these are the details given here. It is going to attach. That looks like this, looks like this. This looks like this. Now, so that's the first question has been completed. That is the draw the detail component drawing. So once again, just have a look. So it is very simple, very easy. These are the parts. Once again, let me tell: the fork end, then the eye end, the taper pin, the collar. Sorry, the fork end, eye end, the pin, collar, and the taper pin. So that completes the first part. As we know, what is the second part? The second part is fits and tolerances. So what kind of the fit going to get? So where we can find the fit here? As I said, the fit we're going to get here. So just you can see here, one type of fit is here between the pin and the fork, the pin and the fork end, and we'll get one more is the fork end and the eye end. These are the two types of fit you're going to get. So let me see that in detail. Let us see the in detail. So what kind of the fit you're going to get? As I said, only the pin and the fork end or eye end. Between the pin, the fork end and the eye end. What kind of the fit you're going to get? That is H8D9. Loose running fit. So loose running fit. Then the fork end and the eye end. These two come in the contact. So that will get easy running fit. So it will be more clearance. Then here H8, E8. See, these are the things we're going to get. Then surface finish. What about the finish here? I said the 12.5. Just you refer the previous drawing what we studied. The previous one what we did is tool post. The tool post for this kind of this thing finish, you have to see the bill of material. Very one of the easy way. So if you see the bill of material, the process given here, the forging. The forging is nothing but, so if it's a forging steel, the forging operation is, it is 12.5. It's come out the class of N10. So again, this is the one. Just revisit 12.5. This is the N10 planing shaping forging. This is N10 class. So that completes the second part. So let us see the next one. What's the next one? So surface finish. The geometrical tolerance and surface finish. So surface finish over the geometrical tolerances. The geometrical tolerances which deals is so let us see the next part, the geometrical tolerances part. So what kind of geometrical tolerances we are going to get here? So let me see. So let us see the geometrical tolerances we are going to get is what type of tolerance we are going to get here. This is concentricity. So concentricity is very, very important. So take this as a reference A with respect to this circle, this, and the concentricity. Just you can focus this. This is the reference A with respect to this. With respect to A, what is the center of this? This is the concentricity. Then again, for this pin, very important. Straightness is very, very important for this prospect. Again, if you see this here, yeah, this eye end, we want the perpendicularity with respect to A. So A, the datum is what with respect to B. This is the base with respect to this. I want the perpendicularity with this. We are going to get only one is a straightness, perpendicularity, and a circularity. That is concentricity. These are the three things we are going to get. So these are the geometrical tolerances. The last part is process sheet. So as we know what is the process sheet again. Once again, it is same thing. The process sheet is nothing but it is a set of manufacturing process instructions, a specific batch, then the lot, Then it's going to describe the machine used and what the operation time. That consists your process sheet. The process sheet of, so I selected here pin, the process sheet. So same thing, the figure name, what the component name is, the figure name we can write. Then the description, what is it is a pin. So again, what is the material is MS mild steel. Size is, you can see the size which is given in the bill of material. From there you can select it. So 40 into 100, the quantity 1. Now this operation, I can serial number, machine operations, tooling, and gauge and time. So we see that the sequence number 1, check the raw material by vernier. Then fix the job into the check again by lathe machine. Then face the end of the facing tool. Then turn the turning tool. Then reverse the job once again. Turn dia 38. So dia 38 you have to turn, and after 12 face, after 12 thickness again you have to face it. So facing tool. Then drill the hole. So hole is drilled. We have to drill the hole for drilling. Then taper, rim, and 5 mm. For drilling the hole, you have to drill here. So because you have to connect with the taper pin. For that purpose, you have to drill a hole, the dia 4. Then after that, the taper pin has to come in to connect here. So finally, inspection. Start with inspection, end with inspection. This completes your process sheet. So that's completed our knuckle joint of production drawing of knuckle joint with all respect. So that's complete production drawing. Now, so that completes our knuckle joint. The production drawing, complete production drawing of knuckle joint. So any doubts, any suggestions, any comments will be welcome. Please let us know in the comment section. And next we're going to do the screw jack.